You all familiar with Excel, right? Doing calculation, what's on. So let's wait a bit. How you do? So first of all, you see this table. Okay, up until this table. Okay, I imported the data from International Energy Agency. So you go here to this statistic, and you energy balance statistic. And then you can Google your country. What is your country? Amira. Amira, I think Indonesia. Yeah?
Yes, Indonesia.
So you take Indonesia here, and you extract this information, all of this information from this is energy balance of Indonesia. Yeah, these things. Okay, you transfer into, actually transferring was not that difficult, I think. Actually, you can easily copy paste this one. Yeah, you got it. Okay, differentiate. Then let's try this. Okay, oh, cannot. Need to do one by one. Somehow I could do. Okay, easy. Copy, make table, you go here, home, and you do this. So get a table. Next, you just need to cross check one by one. So I make, for example, here, items, total energy first. So this one I'll just copy. Oh, different. So item, total energy supply, total energy supply. So this is on the first sum. So I just highlight it here. So what is the first sum? So basically this one. Oh, all of this one is not a number, yeah. They're coming with space, so you need to edit a bit. This is number. Okay, you just cross check. Remember here, 2878787. So this is equal to sum of the one in the above. Okay, it's the same. Sometimes you see the last digit, they differ. That is because of decimal point. So just take it that way. And then you correct this. Okay, then you go next. Just try to Excel. It sounds simple, but in your professional job, it will most likely be the most used software. So try to master to add all some. I can drag from here, meaning that I copy just the equation, go to the right. Okay, all must be okay here. But now this is 0 because the one above is not number. There's space in it. So check. This one, check. This one. Okay, this one actually sum of the one on the right. Sum of this one. Okay, and I will drag here. When I drag here, it means that I drag the equation. Oh, something not correct here because here is supposed to be space. Anything I miss? Okay, this part already okay. And all of the value on the right here is actually the sum of the one. Okay, this one is the sum of the one on the left. So then this is equal. So this is how it says this equal sum of all of the cells. So now I'll copy the equation here up until total energy consumption. Okay, that's it. And then this one is another highlight. Okay, and then you do check the number one by one. So this is 150. That's fine. This one is not fine because you have space. You have space. And more or less, this one will give you 278, the middle. So it's not, if I'm not mistaken, this is not correct. You cannot just sum it. Let me check. Yeah, somehow the balance it is not here. So the way I did was wrong. So this number we just are you guys still following?
Yes.
Okay, good. Oh, go there. I mean, if you know how to do this one, you already that is already a very good skill. I mean, you can work at a lot of international companies or organization that do this one. It looks so basic, but not many will be able to do this. Okay, so here. Okay, the step here is just to check. Okay. Here, check. Here, check. Check. Okay, this one. Here. Okay, so the right side already sum by itself. Okay, that's the one here. The last one doesn't add up, so it's not nothing to sum. Is you just need to correct the format. There might be a way to do the formatting, the fast way to do formatting, but I don't have time to search. Maybe you can Google how to do this. I mean, this all of this space just to make it into simple number. I'm quite conservative, so I'll just do it one by one. Okay, so this one. Okay. Okay, one more column. Okay, so all number already set. The next one, go to the left here. So the next one is to find out the emission. Yeah, the emission was okay. I'll just copy this. Okay. Okay. In this one, before you can calculate it, you need to find out the energy consumption that actually consume the fuel for energy. Okay. For example, yeah, look into Brunei's case. For example, here, so this is the supply, this is transformation, and this is consumption. Okay. What you need to know is that not all energy consumption, therefore energy, not all fuel material consumption for energy. For example, it's stated here it is non-energy use. So basically, non-energy use here is most likely is not through burning. So I exclude this number from emission calculation. Okay, so you look here, this is not emission, this one is not emission. Okay, that's number one. And then here it is stated for industry. So I would assume at this time, because we are working with a very macroscopic data. Okay, so we just make assumption. Okay, the best way is you go search and then you find out how industry use oil product. Okay, but in this case, I would think that it goes to petrochemical industries. For example, it goes to Hengi in Brunei. It goes to Hengi. This petrochemical oil product must go to somewhere, not for energy. So I will exclude it from calculation. I label it here as, you know, what color is this? Okay, another thing is, for example, here, electricity used for industry. When you use electricity in industry, so you just use electricity. You don't emit anything. Okay. So we don't emit CO2 like when you use your electricity at your home. So you don't emit CO2 or the other gases. So here is also excluded. This one excluded. This one excluded. Yeah. Okay. So next, transfer is something. It is just transfer, so there is no conversion. Wind, solar, blah blah blah. We know it. They don't emit things. They don't emit energy. They don't emit CO2. So this one excluded. Okay. This one, when we talk about transformation, negative means you consume. Positive means you produce. Okay. So here, it's consume electricity. When you consume electricity, you don't emit anything. Okay. This one is electricity. Okay. This one is no. Okay. And CHP plant, basically what you can read from this is combined something power plant. Okay, you can check. So here, if you look into this row, so basically this plant convert natural gas, negative, and produce electricity on the right. So this is an electricity produce. This also electricity produce. So all here is the balance of electricity production. So I'm going to put it as non-emitting. Okay. Oil refinery consume crude oil. here and produce oil products. So there is no emission here. Okay, there is no emission here. So this is also spread. So we're left with something. Okay, we're left with something. What? Okay, here residential oil product. This one is I don't know the classification, but if you check on the guideline, so here it's like you know, petrochemical product can be a lot of things. For example, here the plastic, polymer, and blah blah blah. So things that derive from oil product. So I discount here from emission production. So we left with the rest. Okay, so now I will check one by one. This guy here. Okay, this guy here residential. So this is actually natural gas. So this is actually the liquid LNG, liquid natural gas. So the one that you use for cooking at home. Yeah, this one is actually the one we use for cooking at home. Transport, this is supposed to be your petrol. Okay, transportation, this is supposed to be the petrol. Losses here, losses actually mostly is during the energy transfer. So I would say this come from heat loss during the combustion. Okay, so your ability to distinguish between which account that emit pollution is very important. Okay, this one then is count. Energy industry own use, I would say this one is not absolutely true, but I would say this is the energy that is used by the energy industry. For example, you need to power your machineries and so on, and then you can and this one is used from natural gas. And this one is from oil product. CHP plant is basically power plant. Okay, electricity plant is power plant. And electricity plant from oil product is also power plant. Coal here, I have nothing, but I have no idea of what Brunei use of coal, apart from electricity. So I assign this one also as combustion, that emitting the carbon. And in statistical difference, you might argue with me, but this one is just to balance the statistic book, I mean, the calculation. And then in this case, I attributed them for also emission production. So all part that I label green, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, I assign them as an activities that actually burn the fuel and emit the polluting agent, which is the CO2, CH4, and nitrogen. Up to this point, anyone want to ask questions?
No question.
Clear, yeah?
Yes.
Amal, are you okay? Haifa? Yeah. You got it? So next one is a little bit, so this one is based on your smart judgment. Yeah? So when you present your data, I will ask you, well, for example, why you exclude oil refinery, for example, like this thing. This is how I want to test your knowledge. Yeah? How you, why, for example, you discount this one. So you explain the things. For example, another question is why wind, solar, you exclude it from the emission calculation, for example. Okay, so next, okay, we want to calculate the emission. Okay, so the emission, there are 3 items, which is carbon dioxide. Here the unit is kiloton, methane and nitrogen dioxide. These 3 have a conversion factor sulfur dioxide and particulate matter, although they are also important for air pollution, I don't find where I can get the things. You see, when we learn about pollution, we use another books. When we learn how to calculate the emission, we refer to another books. So for these two, up to this point, I cannot find where we can get a conversion. Okay, so now we go for conversion. Okay, so this is you look here. This is a coal. Coal is for electricity. So electricity comes from combustion of the coal. So then we check from the table what will be the combustion of the coal. Okay, this one stationary combustion in energy industries. So you look here, energy industries, stationary combustion. So stationary here, including the machineries, the power plant, you don't. Okay, and then it's coal. So coal, you go down, and actually there are plenty of coal product. Yeah, I use lignite. Here I use, sorry. So I use lignite. So you know this is 101. So what I do, I use absolute here because you see I use absolute here because some of the value above is negative. This above is negative, so it is impossible to get a negative emission. So I just make it positive. 101,000 here, it is the emission factor, and then C12 is actually this guy, the total energy, and 1 divided by 1 million here, which is to make it as a kiloton here, because when you do the what is it, when you in the conversion, it is in kilogram, okay? Kilogram of greenhouse gas. Okay, that is for coal. Okay, okay, we calculate first for CO2, and then the next we also use the same table here to calculate for methane and nitrogen oxide. For methane, the conversion is 1. And for nitrogen dioxide, the conversion is 1.5. So if you look into the Excel, you see here it is 1, okay, for methane, and 1.5 for nitrogen dioxide. Okay, multiply by that. So basically, we finish with coal. Okay, we finish with coal. Next, we go for oil product. Oil product here, if you look, I split it into 3. Okay, I split it into 3. Okay, the first 3 here, E11, this guy, E12, and E20, I assign them for diesel. Because I don't know which fuel is this. It can be kerosene, can be there are a lot of, if you look into the table, there are a lot of different oil. Can be jet kerosene, can be other kerosene, can be crude oil itself, can be or emulsion, the different type. Then you have a gasoline, different type of gasoline. So, but for the first, because I know most of the power plant use diesel fuel, so I use diesel fuel actually, and then I use this data. Okay, so it's 70. Let me check if I do it correctly. So it's if you look here, it's 74,100 for this guy, and this guy. Okay, that's a diesel. Okay, and then next is actually for E24. E24 is transport sector. Transport, okay, it can be mostly 2 options, either gasoline or petroleum diesel. And then I look into statistic data. of the transportation, I found out this one. Okay, all assigned to land. First of all, I assigned to land transport because Brunei for water transport is very small compared to the land transport. So I ignored the river, so the water transport like boat and others. We got no train, so I just assume it's a land transport, and it is, I read somewhere from Land Transport Department Brunei. So I do some googling. I found a data of 23% diesel fueled vehicle. So basically, what I did here was, so I multiply this one. You might argue with me. For example, it's just a number of vehicles, 22.9%. It's not the fuel consumption. Well, yes, that is correct. The more detailed information you get, for example, someone come to me like, I have a better, more reliable data. I have actually the sales of diesel and the sales of gasoline data of Brunei. Now you can use that data, it's better. Okay, because now I managed to only get this data while I was. Okay, this is just for education purpose, but I'm just telling you that you can come with better scenario. Okay, as we will learn later on, when you have more disintegrated data, I mean more detail of data you can provide, you can come up with more precise estimation, and then better policy. Okay, so here, the assumption here is that there are 22.9% of diesel fuel vehicles, and then I assume each vehicle consumes the same amount of fuel, which is not true, because, for example, I drive different kilometers than you guys. Okay, so my car will consume more gasoline than your car. It is not. So you can argue with that one, and then the fact that you can argue with that means that you actually understand the limitation of this assumption. Okay, so here I assign for that. Okay, so this is for transportation. This part is for diesel. Okay, and then the other part is for gasoline. Okay. So this one settle methane. You see, methane got the same calculation. Okay, the only difference is that now we use different coefficient. 3 for diesel, okay, 3.9 for vehicle, and then this one is, I think, 33. Let's just check. Okay, diesel 3, yeah, this is correct. So remember, this is energy industry. So I go to another table to get for manufacturing, construction, transport. I'll try for not transport, commercial. I think I use another table. And table 323 table is, I think, page 90. Okay, because this one is more accurate. Road transport default. So I use this data. You get motor gasoline 69 default. Gas diesel oil 74,100. Where is the SOX? What table is this? 321. 321. Okay, 323. Where is 322? Okay. This one also road transport. There will be no big difference. So N2O and C4 for gasoline and diesel vehicles. So I use this data. The thing is, I mean, if you look here, if you have more specific information on what type of vehicle, you can come up with more accurate estimation. but we don't have the data. So which one I use? So I use this one. So this is methane default. This is uncontrolled, I said, and this one is diesel 3.9, 3.9. Let me check that. 3.9, 3.9. So it's 33, correct? This is 3.9, yes. Moment. Okay, and then for nitrogen, the same. So we go into also this table for NO2. So we get 3 more things. Next is gas. Natural gas. Natural gas is consumed there too, yeah. You check here. So we got this guy, F11, F12, F13, F11, 12, 13, F20, F20 and F21. I assign this one to natural gas, normal natural gas, the one in table. Natural gas for energy. So I use this one. Okay, natural gas, 64,200, that's correct. No, 56,100, which one? Diesel, gas, oh, sorry, gas. Gas is somewhere down here. Yeah, this one, natural gas. Okay, and the one down, is remember we have one left, which is F25. F25 is gas for residential. It has to be LPG, liquid petroleum gas. Okay, and it's 64,200. 60 LPG liquid. Where is it? Liquid. This one, liquefied petroleum gases. Okay, or this one, natural gas liquid. I don't know which one is. You have to find out. I think it's supposed to be LPG. This one, 63,100. Small difference. Okay, that's for gas. And then methane, you use a corresponding table. So after you finish calculation, you sum it up. Okay, you sum it up, and then you just do calculation. So I find out the information from BP statistic. This is the total CO2, global CO2 emission 2019. So it's around 34 trillion ton, 34,000 million ton. So it's gigaton. Okay, and I checked 2019 also the global population 7.7 billion. So total per capita is, this is simple. So the total emission divided by the total population. So we get the emission per capita of us on Earth is, we emit around 4.5 ton CO2. Of course, this is from one to another, we emit different, but the average is around 4.5 ton. And then when you look into Brunei Darussalam, so our global consumption, so I just fraction of this one divided by this one. Of course, using the same unit, yeah. Using the same unit. This one is in kiloton, so I make it into million ton here. to million ton. I divided by this one, I multiply by 100%. So we get around 0.021% of the global population, which quite makes sense. Kan? Then we check from, I forget, from Wikipedia or something, or statistic of data, Brunei population 2019. Now I know the exact number. Today is like 444,000 Brunei population. So 2019 was 433,000. Then we managed to calculate a ton CO2 per capita, which is here, which is the thing here. So remember the CO2, we make a unit of kiloton before, so I make it into ton and then I divide it by the number of population. Okay, so we get we consume average four times above average of global population, which is makes sense. Yeah, if I find around, for example, 4, that will not make sense, because you Bruneian, each of you got a car, so that's very simple compared to probably some population in Indonesia, for example, or even in European. I mean, 1 in 5, I think, a car. One, yeah. Brunei is, I think there are more cars than people in Brunei. Okay, that fact helped me to digest this information, validating if this makes sense. Okay, the next is what is the ratio to the global per capita? So that is basically how many times of Brunei consumption. So which is 3.7 times higher than global.